Hi, welcome back. In this video, we'll discuss topics specific to sensation and perception. Just to give you a big picture, the topics we have discussed so far are specific to the basics, the big picture. In the basic section, we went over the history of psychology. Then we also went over the brain and behavior. Now we're going to move to the third topic, sensation and perception. Okay, so sensation and perception. So what is the difference between sensation and perception? Oftentimes we use these terms interchangeably in a day-to-day context, but for this particular topic, for this class, we're going to differentiate it and try to really understand what these two constructs mean or doesn't mean. So if you think of the external world and yourself, you have 5 sense organs that are specifically designed to capture information from the external world. Information such as light, sound, chemicals, touch, temperature, pressure. These raw energy will be captured by your sense organs. And that is what is called a sensation. Sensation is not our conscious experience of it, which is more of perception, which you do when you interpret the information that's being sensed by your sense organs. So sensation is merely capture of information by your sense organs. So we have different sense organs for different kinds of raw energy in the external world. We have eyes for light energy, ears for sound energy, nose for chemical energy, skin again for touch, temperature, and pressure energy. Then we have tongue for chemical energy again. If sensation is mere capture of information by your sense organs, then perception is how your brain interprets it. So you can think of sensation as a localized process happening at the level of the sense organs. Then perception is at a higher level happening in your brain. So for this topic, we're going to talk first about sensation. In sensation, we're going to first talk about what sensation is. Then we'll talk about different modes of sensing. Then we'll move on to the key constructs in sensation in general. So what is sensation? Now, as we just discussed, sensation is a process of, it's a process of capturing energy, but to put more precisely, it's a process of transforming this. In capturing this external energy, what sense organs do is they transform the external energy or stimulus, like light energy, chemical energy, temperature, touch or pressure energy, into electrical signals, also called neural impulses or action potential. This process of transforming this raw energy into electrical signals is called sensation. Where does it happen? Well, as I said, it happens in our sense organs. And the next question is why? Well, I often say that our brain is too stupid or to actually directly process information in its raw form. It can only understand or process energy or physical energy in electrical signal form. It can only process electrical signals. So there should be a way in our system to convert this raw energy into electric signals, and that's what our sense organs do. Who does this transformation in sense organs? Well, there are some special cells. In fact, these are special neurons in our sense organs. We call them sensory receptors. These sensory receptors are specialized neurons that can transform this raw energy into electrical signals. Are these receptors stimulus sensitive? Yes, they are. Not all receptors respond to all kinds of stimuli. Um, for example, there are photoreceptors that are only sensitive to light in your sense organs, in the eyes. There are two kinds of photoreceptors, like rods and cones. And we'll talk more about it when we talk about light perception or color perception. And there are specific cells called mechanoreceptors. These are for perceiving or transforming sound waves into electrical signals. These mechanoreceptors are like hair-like cells, right? And these are in your internal ear. And these are specialized to transform sound energy into electrical signals. Then we have chemoreceptors, chemical receptors, receptors in your taste buds that transform the chemical in the food you eat into electrical signals. And we also have chemoreceptors in our upper nostrils. These are sensitive to chemicals, and again, they transform them into electrical signals. We also have different kinds of receptors in our skin. For example, there are nociceptors in the skin. These are sensitive to movement, touch, pressure. There are also thermoreceptors that are sensitive to cold and warmth. These are basically sensitive to different temperature gradients. If you think about it, our body has different specialized cells in these sense organs. So we can capture information from the external world and send it to the brain. And because brain cannot understand information as is from the external world, sense organs help us transform this can help us transform this raw energy into a form that our brain can understand. And we discussed in chapter 2, it's the electrical signal format. And if you remember from history of psychology, we talked about psychophysics, right? So the field that looks at the relationship between stimuli and receptors response is psychophysics. And if you remember, we considered this field as this phase of mid 1800s, around before psychology was actually born in 1879, right? We said there was some research, and specifically in psychophysics field, that helped eventually psychologists to adopt scientific methods to study human mind. And first of those kinds was the structuralism, right? And we talked about two psychophysicists, and one of them was Fechner. And Fechner in 1860 he published his book Elements of Psychophysics. And in this book, he talks about different factors, how they affect our sensations, right? So we're going to talk about some constructs that Fechner developed and in trying to answer this question. For example, what factors affect our sensations? There are several factors. There are some factors related to the individual itself who's sensing. There are factors related to the environment that you're gathering information from. And also, most importantly, there are some factors specific to the stimulus itself. So we're going to talk about the stimulus-specific factors that influence whether or not we sense information. And for us to get into some specifics of these, we need to talk about these constructs. We'll talk about threshold, we'll talk about signal detection, and we'll talk about sensory adaptation in that order. So our second objective is, what are some commonly asked questions in the field, right? If sensory receptors are sensitive to stimuli, then the question is, how sensitive are these? In other words, do they respond to any amount of stimulus in the real world? Or is there a need for the receptors to have a specific amount before they can, a minimum amount before our receptors can actually sense information? Now, do they need a minimum level of stimulus to respond? Well, Fechner came up with this concept called absolute threshold. Absolute threshold is this minimum amount of a stimulus. It's the minimum amount of the stimulus, the smallest amount of the stimulus that can reliably detect. Now keep in mind, we're using the word reliably here, referring to the fact that there are 50% chance of detecting it and 50% chance of not detecting. It's that twilight zone. It's the zone where there's equal chance of being detected or non-detected. And Fechner measured the absolute threshold for various senses. Absolute threshold is defined as the minimum amount or level of stimulus energy that we can detect reliably. In this case, we define it as 50% of the time. If it is less than 50%, we call it sub-threshold, below the threshold. If the chances are higher than 50%, we call that above the threshold. Now, a related question is, can we detect changes in the quantity of the stimulus? For example, you're eating something sweet. If we add more sweet, can we detect the increase in sweetness? Or if there is an increase in volume in a specific sound that you're hearing, can you detect the change in the volume? Well, the answer to this question is yes and no. Yes, in the sense that we can detect, but not all the times. Now, the amount of change in the stimulus that need is to be a very specific amount. What is that difference amount? Well, the difference amount is defined in terms of a construct called JND, just noticeable difference, or the difference threshold. It is the minimal difference between two stimuli. So there is already salt in the food and you're adding more salt. What is the difference between the amount of the original salt and the new salt you're adding? That you can reliably detect. That's the just noticeable difference. And it's not always same. For example, if a food is less salty, and if you're adding a little bit of salt, then that's enough for you to detect. The food is more salty, if you're adding a little bit, same amount, you may not detect the change. So the just noticeable difference is not a specific amount, but it's a specific fraction of the original amount. And Ernst Weber is known for this idea of just noticeable difference. And according to Weber's law, just noticeable difference is a fraction of the original signal. It's not how much, it's not constant by amount, it's constant by the fraction of the original one. So if you have 5 grams of sugar, then just 1 gram will be sufficient. If you have 10 grams of sugar, you probably need to add even more than just 1 gram. And it is defined by a fraction, and it's always constant for a given sense. For example, Weber's constant K, which is a fraction of the original stimulus, we have these numbers or different Weber's constant for different senses. For example, for pressure on skin, the change from the original pressure has to be in a fraction of 1/7. And for loudness, it is 1/10. For odor, it's 1/20th. For weight, it is 1/50th. And for brightness, it is 1/60th. And for pitch of the sound, it's 1/333. And for saltiness, it is 1/5. Now, the second construct we're going to talk about is called the signal detection. Now, if you remember, we asked a question, what factors influence whether or not we sense information? We said one of the factors is the stimulus itself, right? But there are other factors that influence whether or not we can detect information. So these factors include the signal itself, which is nothing but a stimulus. Then, according to signal detection theory, there are several other factors, including the individual itself. Now, before we move on to these things, I just want to give you some idea about this hit and threat rejection. So what factors influence signal detection? There are several factors, as we said. Number one, the stimulus itself, the strength of the stimulus. So there are some factors specific to properties of the stimulus. Then the background noise. There is more background noise, then you're less likely to detect the change. If there is less background noise, then you're more likely to detect stimulus. Then the characteristics of the person himself or herself. So some people are more sensitive to some stimuli than others, stimuli or than other people. And so individual sensitivity to specific stimuli may also play a factor, play a role. Then the biological condition an individual in. For example, if you're cold, then your sensory receptor specific to smell may not be that active. Or if psychological conditions like hunger. If you're hungry, then you're more likely to detect the smell of the food. Can our receptors become non-responsive to the stimulus? Well, the answer is yes. Just imagine if you eat something sweet like cupcake and then drink Coke. Do you think it will be sweeter? I don't think so, right? That's called adaptation. Adaptation is when your sensory system becomes less sensitive to the changes in the stimulus. Now this brings us to the next topic, which is visual sensation and visual perception. And we'll continue with this topic in the next video.